Researchers at the Lawrence Berkeley National Lab have been figuring out how to turn plants into biofuel to one day replace fossil fuels like petroleum. However, in their quest to engineer the perfect plant, they've stumbled into a solution for one of the most important products for babies: infant formula. Since its invention in 1865, formula has become an essential product for many families. It provides the nutrients, energy, and hydration that kids need, but even today's brands still can't compete with the real thing. Dr. Patrick Shih says one reason is that breast milk contains human milk oligosaccharides, or HMOs. These are milk sugars that support gut health, immunity, and brain development.
These HMOs are known to promote the growth of specific types of bacteria in a baby's gut. And ideally, you would want to promote the healthy bacteria, the quote unquote healthy bacteria, to be sitting there blocking out, essentially like blocking out these bad bacteria. And so you have to give the right type of food so those good bacteria will be living in a baby's gut. So what is found in breast milk, but not infant formula specifically, are these diversity of complex sugars that we call carbohydrates or oligosaccharides, HMOs. There's a reason why breast milk is arguably like this perfectly evolutionarily, this really evolved thing to be the perfect nutrition for a baby.
She is an assistant professor in the Department of Plant and Microbial Biology at the University of California in Berkeley. There's around 200 different HMOs found in breast milk, and though there's an entire industry trying to replicate them in infant formula, she says we're making slow progress.
To be very honest, right now, with an entire subfield and industry kind of working on it, commercially, we can only really make around 5 or less of these HMOs. That's one of the reasons why we were attracted to this problem. So primarily, what's done in industry is actually producing these oligosaccharides in bacteria.
These bacteria have been engineered to create HMOs through fermentation.
We've been fermenting things for a long time. It's not just beer. More recently in biotechnology, we can ferment microbes to make various compounds, plastics, drugs, whatever you want.
However, Xi's lab has taken a different approach. Though his team set out to create new biofuels, they realized the potential for using plants to produce HMOs. Instead of using fermentation, Xi has engineered plants that can create these carbohydrates simply through the process of photosynthesis.
It's taking CO2 out of our air and converting it into sugar. And so I like to very simply think of plants as like sugar-producing factories. And so all what we're doing is trying to reroute the sugars that are being made by photosynthesis into making something that is beneficial for an infant. So the pros there is that, this is photosynthetically produced. You're directly converting CO2 in our atmosphere to whatever product you want. The inputs are really low. All you need is water and sunlight, and you can grow these things on a massive scale, like agricultural scales.
Xi's recent paper published in Nature Food proves that this method works. But how do the HMOs that we engineer compare to the natural ones found in breast milk?
The specific HMOs that we were targeting are exactly chemically the same. One of the things we did in our study was to actually optimize the way, this was with Daniela Borelli's group at UC Davis, who really specializes in this area, where they were able to really optimize a nice process for actually extracting the HMOs from our plant material. And then we worked with David Mills, also at UC Davis, to feed our extracted HMOs to the specific good bacteria isolated from infant guts. And we could demonstrate that they grow on the specific HMO, just like if you isolated a specific HMO from breast milk or if you bought one from a company. So we know chemically they're exactly the same. And then functionally, when we've actually done those experiments, they look the same.
And while the current method of fermentation can produce a couple of HMOs, Xi's new plants can already create more than a dozen. And this is only the beginning.
What we're hoping for is, it's not too inconceivable to imagine trying to go for all of them. I know a couple of years ago when we started this project, I was worried that we wouldn't even be able to get one of them. But it worked pretty well, again, because plants are these sugar-producing factories. A lot of the underlying blueprints, like metabolism that you need to do this, is already lying there in a plant.
But while Xi's got the science figured out, there's a lot of unknowns in terms of production and manufacturing, since this is a brand new concept.
We're part of this kind of smaller subfield in academia that's really actively trying to explore how would you try to imagine commercializing this technology? How would you make that leap into engineering plants for a bunch of different purposes?
While this research may have started with biofuel, she believes the sky is the limit when thinking about what types of products can be made by plants. Specifically, when looking at the ability to produce HMOs, being able to include all 200 into infant formula one day would be a complete game changer. You can find more information about Dr. Patrick Shih and all of our guests on our website, radiohealthjournal.org. For more behind the scenes, follow Radio Health Journal on Facebook, Instagram, and X. Our writer-producer is Kristen Farah. Our production manager is Jason Dickey. I'm Greg Johnson.